All right, so I'm going to go through 5 questions from the Google form that you guys filled out for finding the force or the mass or the acceleration, because these 5 questions seem to be the ones that people struggled with the most. At least 20 people got these questions wrong, which then means that about a third of the class got these wrong. So that's why I want to go through these. All right, it is mandatory for everyone to watch these, but let's just go through them real quick. Remember, for all of these formulas, or all these problems, we are going to follow the formula that force is equal to mass times, I don't want to use the x, mass times acceleration. So for all these, we're going to be figuring out, do we know our force, do we know our mass, and do we know our acceleration? And if we know what they are, we can substitute into that formula. So pushing over the file cabinet to keep out the zombies requires 1,000 newtons of force. So right away, they're telling me that this is my force. It tells me flat out because it says a force. But even if it didn't say this, we know that when we see our units be newtons, that's talking about our force. So I can substitute this in. So I have 1,000 for force. Then it says the cabinet accelerates at 20 meters per second squared. So once again, they're telling me right away that it accelerates. So this is where it's going to be accelerating at 20 meters per second squared. All right, I'm going to write the units in for these, but we're not going to write them into our actual formula. And now it says, what is the mass? So this is what we do not know. So I'm going to plug in all of our variables that we know. So for F, instead of it being F is equal to M times A, it'll be 1,000, because that's what our F is equal to. We don't know our M, and our A is 20, so it's going to be 20 times our M. And then we will divide each side by 20 to go ahead and isolate our variable. And when we divide this by 20, that is going to give me 50. So our mass is equal to 50, and it will be kilograms. All right, our mass for these is always going to be kilograms. We are going to get into a video that will go over why it's kilograms and how we can get that through our units that we're starting with. But for now, anytime your mass, it's just going to be 50 kilograms. In your Google form, though, you would have just written 50 just to make it easier for you guys to get it right. All right, so now I'm going to pause. We're going to go on to the next question. All right, so once again, we're using our force is equal to mass times acceleration. So that means in this problem, I'm going to write out what force, what mass, and what acceleration is equal to. So Abby, who has a mass of 55 kilograms, so right away I can substitute in, or I can write for my mass, 55 kilograms. So she ran from the zombies to hide in a closet. What is the force required to accelerate her at 5 meters per second squared? So they're telling us that if her acceleration is 5 meters per second squared, what is her force? So this is what we do not know. So this one's going to be even easier, because now when we substitute in, we don't know our F. We are simply going to get 55 times 5. And 55 times 5 is going to be equal to 275 newtons. All right, but like I said, on your answer, you would have written 275 just to make it easier for you. Since you're getting immediate feedback in these Google Forms, it makes it easier to allow that when you just write the numbers. But if this were a test that you guys were writing for me, writing it out, you would be writing it out like this. All right, let's go ahead and move on to the next question. All right, same thing. We start out with writing our formula, force is equal to mass times acceleration, and then we're going to write out all of our different variables and see which one we're given and which one we're solving for. It says Alan pushes a cart into a crowd of zombies with a force of 225 newtons. So even if it didn't say a force, once we see the newtons, we know that this is going to be our force, so we have 225 newtons. If he accelerates the cart at 5 meters per second squared, once again, acceleration, that means that where we see acceleration, we can say it's 5 meters per second squared. What is the mass of the cart? This is what we do not know. So once again, we are going to be plugging this in. Force is equal to mass times acceleration. So our force is 225. So I can substitute 225 in for F. My acceleration is 5, so I'll substitute 5 in for A, and we write it as 5m. Remember, we do not write our coefficient behind it like this. That is not correct. We would always write it as 5m. All right, and then we will go ahead and divide each side by 5. And our our mass is then going to be equal to 45 kgs. But remember, on your Google form, you would have just written 45 to make it easier for you guys to fill out. All right, so it's really not that bad. You should just be writing out these variables off to the side and trying to identify what each variable represents. And then you just plug it into your formula. And from there, it's just solving simple one-step equations, which we're going to dive into deeper next with our math. All right, so once again, we start with our formula. Force is equal to mass times acceleration. I'm going to write my force, my mass, and my acceleration. It says 4 students sit on a zombie and hold him down. Hayden's mass is 57 kg, so I know I have 57 kg. And then it says Cindy's mass is 50 kg, so I know I have another person that's 50 kg. And then it says Tanner's mass is 60 kg, so I have another person at 60 kg. And the last one, Daniel's mass, is 63 kg. So what we need to do is we need to think about this for a second. Are we going to look at these individually? No, we would have to add these up. Let me just subtract this or erase this and move this down a little bit. No, we would have to add these up because if they're all sitting on top of the person, then that person is feeling the mass of all of them combined. So it would simply be 57 plus 50 plus 60 plus 63, which is equal to 230 kg. So this is what we're going to use because if all of those people are sitting on a zombie, he's feeling the mass of all of them combined. And we wouldn't multiply these together like some people were thinking because just imagine if you were sitting there and you had 2 dogs that were sitting on your lap. I know it's not looking like dogs, but we just have 2 dogs that are sitting on your lap. Well, if they're each weighing 5 kg, if they're both on your lap, they can't all of a sudden be 25 kg. That just wouldn't make sense that we're multiplying them together. If they're both sitting on your lap, then you would use them both together and add their weights and say, well, we had 10 kg on us. Right? So that's why we would have to add all these together to figure out what the total mass is that is sitting on top of this zombie. And then it says what force is exerted on a zombie. And it says use 10 meters per second squared as the acceleration due to gravity, because that would be gravity pulling them down. So it'll be 10 meters per second squared. What is the force? Once again, this one's a little bit easy where we're just going to plug it in to our formula. We don't know our force, so it's just equal to. Our mass was a total of 230 kg, and our acceleration was 10. So when we actually multiply this out, our force is equal to 2,300 newtons. Or like you would have written in your Google form, it's just 2,300. Remember, I told you, do not write commas for this one. Just write the 2,300, right? Because in the last one, people were writing commas, and then it was messing things up. So just write the 2,300. All right, now on to the last question. All right, so same thing. We're using the same formula. Force is equal to mass times acceleration. We will write out what our force, what our mass, and what our acceleration is equal to just to make it easy for us when we're substituting in. We're going to go through and read the question. A 6 kg medicine ball. Well, when we just talk about just kilograms, we know that we're referring to its mass. So our mass is 6 kg. It then says was thrown with a force of 20 newtons. So once again, even if it doesn't tell us this force, we know it's force because of its units being newtons. So we have 20 newtons. What is the acceleration of the ball? So this is what we do not know. All right, so then we can go ahead and we can start substituting into our formula. Well, 20 is equal to F. So in our force is equal to mass times acceleration. We have 20 is equal to our mass is 6, and our acceleration is A. And then from here, we will divide each side by 6. And our A is going to be equal to 3.33. I tell you to round to the 10th, so we will just write it as 3.3 because when we're rounding to the 10th, this is the number that we are rounding, so that means we look at the digit after it. Since the 3 is less than 5, we stay where we're at, so that's why it will be 3.3. And our acceleration would be meters per second squared, but remember, you don't have to write that. You could just write, or you would have just written 3.3 as your final answer, right? In order to get this division, which by now you guys should be able to do long division, I'm going to do it right here. So let's just go ahead and we'll say that we're dividing 20 by 6. Well, 26 is not going to 2, but it goes into 23 times. So we can multiply 6 times 3 to get that 18. We can then not multiply, we would then subtract here. So 20 minus 18 is 2. So 6 is not going to 2. So then we need to add that decimal. So that way we can add the 0. When we add the decimal, we add it there. We can then drop the 0. And if you notice, we're dividing it into the exact same number. So that means this pattern is going to continually repeat because we would then do 3 times 6 is 18 minus 20 minus 18, which is 2. We would then add that 0 and bring that one down just like the other one. So that means it's going to end up being 3.33 repeating, which we know is going to round to just 3.3. All right, and that is it for this video. If you have any questions, please reach out.